So it's time to start actually verifying some of these trig identities. Here is the formula sheet essentially that you can use any one of these identities at any time in solving a trig identity and in confirming what we're trying to find. So I'm going to start with some very, very easy ones. First one, tangent times cotangent equals 1. Easiest thing you can do is to first say, well, if all else fails, I can always turn things into sine and cosine. So for example, tangent is sine of x over cosine of x. Cotangent is cosine of x over sine of x. We just knew that from our quotient identity. Okay? And what I can see from here is that, well, obviously, sines cancel, cosines cancel, and I'm left with just 1, which is what I was trying to get. So we started on the more complex side. We turned things into sine and cosine, did basic algebra to solve, and look what happened. We got the identity that we wanted. Okay, here's another example. The left-hand side is going to be the more complex, so that's the side we're going to work on. I can't move things over, divide, anything like that, but what I can do is I can, well, in this case, I can do an algebraic function such as factoring. So when I factoring, in this case, foiling. When I FOIL this out, I get 1 minus cosine of, that fish is the Greek letter alpha. Then I can add the inside and get plus cosine of alpha, and then I get minus cosine squared of alpha. From here, I can just look and see now if there's any algebraic easy things I can do. Well, I have plus and minus cosine. So I have 1 minus cosine squared of alpha. Now, anytime you see something that has a trig function squared with 1, I'm going to be looking at one of these Pythagorean identities. So in looking at this 1 minus cosine squared, hey, here it is. That's equal to sine squared. Hey, perfect. That's exactly what we were trying to find. So equals sine squared. We have to finish it off by saying, yep, that's what we were trying to find. We're good. Check marks. We can move on to our next problem. Let's get into a couple more complex ones. Both of these have the appearance that are pretty straightforward in what we're going to be able to do, actually. For this first one, everything's already in sine and cosine, which is kind of nice. Actually, both of them are. What I'm looking here, though, is that, okay, I could change sine squared using the Pythagorean identity, or I could change cosine squared using an identity. The issue is, which one are you going to change? Do you change one? Do you change both? Use the answers to help figure it out. What I mean by that is, I need something on this side that has just sine squared theta. So I'm not going to change this side here at all. I will change my cosine squared beta, which using that same identity is 1 minus sine squared of beta. This is still sine squared. And then from here again, I can just do basic algebra and get 1 minus 2 sine squared of beta, which is what I was trying to get, which means we finished our problem correctly. All we're trying to do is prove the left can equal the right. Okay? On this one, both sides are pretty equally complex. Just to switch it up, I'm going to change the right-hand side here. What I'm going to do, I know things about cosine squared. I don't know much about cosine to the fourth. But what I can do, since they both have a cosine squared, how about I factor out a cosine squared? If I do that, I'm left with 1 minus cosine squared here on the inside. Well, hey, that's that same type of Pythagorean identity that we've done before. 1 minus cosine squared theta is just sine squared of theta. So now I have cosine squared theta times sine squared of theta. And at this point, what I should be looking for again is use this side to help you out. I want things that are just sine. Well, I know that cosine squared theta, again, going back to that same Pythagorean identity, is 1 minus sine squared of theta. This just stayed the same, and now I can finish off with some algebra and get sine squared theta minus sine squared times sine squared is sine to the fourth. And that's exactly what we were trying to get. So you write it out on both sides. We've proven this identity. Okay, a couple more to look at. Which side is more complex? What I mean by that is which side has more terms. This guy has 2 terms being multiplied, or being added together, I should say. You only have one thing over here in secant, so that's going to be very difficult to work with. So what I'm going to do is I'm going to do something with these guys. There's no Pythagorean identities to work with, so I can't do that because there's no sine squares. There's no basic algebra I can do. When all else fails, what we're going to do is to look to change things into sine and cosine. So what I mean by that is I already have these guys are sine and cosine. I'm going to change this tangent into sine over cosine. From here, let's just do a little simplification. Sine times sine would be sine squared. Everything else is staying the same. And what I have here is a scenario, you'll see this a lot. We have two different terms, essentially two different fractions, that I need to turn into one term. Well, the way you manage that is with common denominators. So I'm going to need to multiply this guy by cosine on top and bottom. That is a legal move because I'm working just on the one side. When I do that, this now becomes cosine squared over cosine. This becomes still, it was sine squared over cosine. So that means that I can now combine those fractions together. Cosine squared theta plus sine squared theta all over cosine theta. And this is the real big one. You should be able to notice that immediately. Sine squared plus cosine squared is always 1. So I get 1 over cosine of theta. And 1 over cosine of theta, going back to one of those reciprocals, the flip of cosine is secant, which is exactly what we wanted to get. Secant of theta, that's what we wanted. Check. There's no right or wrong way to do it. All these methods I'm showing are just the most generic, straightforward ways to verify these identities. So one more here. I'm going to suggest maybe give this one a try. Pause the video real quick, see which side you're going to work on, and figure out what you can do. Remember, you can only work on one side of the identity. Okay, hopefully you picked the left-hand side because there are two separate terms being separated. It's always easier to take two fractions and combine into one. And I say fractions because, well, there's no Pythagorean, there's not much we can do, so I'm going to change first. Our main rule is to try to change everything into sine and cosine. So this is going to become 1 over sine, and this is already sine, so I'll keep it like that, equals cosine theta, cotangent theta. Why did I even write that? I should have even written that. I'm trying to get to that on the right-hand side. So kind of like the last problem we just did, I have two fractions I need to combine into one. The way I'm going to do that is to make a common denominator. I already have sine on the bottom. I need to get sine on the bottom here as well. So I'll multiply by sine over sine. So I get 1 over sine theta here still. This now becomes sine squared theta over sine theta. Combine those two fractions into one now that they have the common denominator. And you can kind of skip steps around once you get more acquainted to doing all this. But you have 1 minus sine squared theta over sine of theta. Hey, 1 minus sine squared. I'm thinking immediately Pythagorean identity. I look at my chart and I get, yes, that's cosine squared of theta over sine of theta. Now at this point, I'm going to take a look at what we have here for my answer that I want. I want something that has cosine in it. Well, that's awesome. I have a cosine. I actually have cosine squared. So here's what I'm going to do. I'm going to separate cosine squared into cosine times cosine. Because now I have my one cosine, and what's left for the rest of the problem should be cosine over sine. And that part should be equal to cotangent according to our identity. Well, hey, cosine over sine is cotangent of theta. So I have cosine of theta times cotangent of theta, which is what it was we were trying to find. Cosine times cotangent. Okay, so there's your first set of examples to look at. Takes some time to practice them. Best thing to do too is to go back and try some of these over and over again because they are very similar, yet very different at the same time. Each one works just slightly differently.